Next, we have the circular rod of charge, and we're going to assume it's a negatively charged rod. That's why the electric field goes into the object. Now, notice something. We have this little chunk ds here, but then we also have like a corresponding chunk ds of charge right there, and that's going to produce an electric field line that goes this way. So what that actually means is we have a y part here and a y part here that cancel. So we only care about the x component of the E field. So we only care about EX because the y parts cancel. So let's go ahead, and I'm going to be a little bit more direct here when I set up my integral. So the first thing is, let's notice for every single hunk of this ring here as we go around the ring, right? And we're going to be integrating. This angle here is actually negative theta. So we're going to integrate from negative theta to positive theta. We care about EX, and I'll write 1 over 4 pi epsilon naught here. And we're going to write this as dq over the distance squared. But now we got to kind of fill in what that means. And we need cosine of theta since it's only the x component we care about. In this case, we actually chose our angle in a smart way if we use SOHCAHTOA. So EX ends up, whoa, that's gross. EX ends up being 1 over 4, okay, 9,000th times its arm. EX equals 1 over 4 pi epsilon naught. And we're going to integrate from negative theta to theta. Now dq is just going to be our density times our little hunk, ds, over r squared. We'll leave cosine theta. Let's be really clear. That r is the distance from here to here. That's actually the radius of the circle times the cosine of theta. Now, just to be clear, when you're integrating a little hunk here, the arc length, let's just be clear, the circumference of a circle is 2 pi r, right? So a little hunk of circumference, basically, and 2 pi r means you went all the way around the circle, okay? If you notice, half a circle would be pi r, right? And a quarter of a circle would be pi over 2r. You notice how pi over 2 is 90 degrees and pi is 180 and 2 pi is 360 degrees? So in other words, if I take the angle in radians and times it by radius, that's my hunk of circumference that I cover. So ds in this case is going to be r times my little hunk of angle d theta that I move through. So Ex is going to be 1 over 4 pi epsilon naught lambda r d theta over r squared times the cosine of theta. We can actually do a little bit of cancellation here. We're going to integrate from negative theta to theta. So a little cancellation here and here. When we integrate cosine of theta d theta, we're going to end up getting Ex equals 1 over 4 pi epsilon naught times lambda over r sine of theta from negative theta to positive theta. When we simplify this out, we're going to get that Ex equals, I'll just leave it as E since it's only in the x direction, E equals 1 over, now here's the thing, when I integrate this out, this ends up being 2 times the sine of theta. So this actually leads this to being 1 over 2 pi epsilon naught lambda times the sine of theta all over r. All right, so that is it for the chunk of ring or chunk of circle or hunk of circle or circular rod of charge or whatever you want to call that thing, this is the field.